Yeah, we didn't practice all these last week. We went to the tag, but we didn't finish everything in there. All right, so today we want to practice actually being able to simplify and find particular values and limits, right? So I'll just quickly going over the limit rules, right? So you have all limit rules, right? Remember, you can pull the K on the outside. You can split it up if it's a product. You can split it up if it is multiplication. You can also split it up if it's a addition and division, right? And please remember that you can also do it if you have it to the format. Okay, so just remember these rules. We'll go back to these rules when we start to simplify limits, right? And the two techniques for simplifying limits are number one, factorization. Number two, dividing by the highest power. Remember to always check if factorization will work first. If factorization doesn't work, then you go to divide by the highest power. Okay? And L'Hopital's a technique to check the answer, right? You're not legally allowed to do that. If you look here at number one, I use the factorization technique. So I factorize, right? I factorize x squared plus 2 into x by x plus 2 and it cancels off here. Then I plugged in, then I got the limit of x approaches minus 2 of x and I plugged in x. Okay, and I got minus 2 as the answer. Everybody okay with that? That's how we did last day, right? That's how we factorized and we got the answer. Right? Please remember, when do you know if to factorize and divide by the high power? When is what? When the limit is undefined, right? So if I plug in minus 2 here, I'll get minus 2 squared plus 2 by minus 2 all over minus 2 plus 2. That will give me 4 minus 4, 0 over 0, which is kind of infinity, undefined. Right? If it's undefined, we have to use number one, factorization, or if factorization doesn't work, number two, divided by the highest power. All right? So you went through those rules last day. I think the next example was a what? The next example was right here. Divide by the highest power. So the highest power is x squared. So I divided each one of these terms by x squared. I got this, this, and this. Simplified to this, and then I plugged in infinity. So I got 3 over infinity, 1 minus 4 over infinity. So this is 0 over 1 minus 0, which is 0. That's okay? So the answer to this is 0. Right. Quick little thing. What is L'Hopital? L'Hopital is a technique that allows us to, oh, by the way, fill out the cash flows form, please. For those who are doing it, fill it out because we're going to advertise it next week, right? So the topic review is in April. I was going to bring them the date on Facebook, on Instagram, you'll see it, right? After, it's the first year that we ever had a full month before exam, after cash flows. So during that month, I'll just be doing revision of certain topics. So during the crash course, I'll ask you if I'll put some topic picture, and if it's tell me PMIs hard, I'll do opposite PMIs. Right? If you find limits hard, I'll do opposite of limits. 1D and limits only. Right? And the question ranges from easy to very hard. That'll be like the lessons time, but like how we have a 3 hour, it'll be like a 2 hours. Right? So, but those classes optional. If you don't agree with the main easy, you can ignore it and you still qualify your whatever you want. Huh? April. It'll be the whole of April. And all nighters will be before. Right? Huh? Right? So let's try these quickly. Oh, I'm going to talk about L'Hopital. Sorry. So what is L'Hopital? L'Hopital is not actual proof. What L'Hopital is, it just allows you to check the answer. Okay? So here what you're doing L'Hopital. You differentiate your numerator, differentiate the denominator, and you put in the answer. Right? If it's still undefined, you try it again. Let me show you what I'm talking about. Differential of 3x's, 3, Differential of x squared minus 4s. Plug in infinity. What do you get? 3 over infinity. So the answer is, that's okay. But L'Hopital is not a valid solution at unit 1 level. So you have to do method 1 and method 2 to get the marks. But you could use it just to make sure you get the right answer. Okay with that? Alright. So as a quick, before we go on to the other rules, let's see if we can work out these 3 here. Always check factorization first. Huh? So let's see if we can do this. I'll give you a few minutes, try that. Well done. Right, so if after it was number 2 and 3. Right, if after you do factorization and divide by the highest power and still get infinity, it means the answer is infinity, right? So we are allowed to get infinity. So let's do Are you ready? What else something now paper? You want to right and forth now? All right, let's go. Let's check out the first one. Or we get to the first one. Huh? No, sorry. So would you be able to factorize the first one? No. It wouldn't be able to factorize. So we have to divide by the highest power. So we're going to get 3x squared on x squared plus 1 on x squared over 2x on x squared minus 1 on x squared. So we're going to get the limit that x approaches infinity. You always have to keep writing the limit until you substitute, right? So you'll get 3 plus 1 on x squared, 2 on x minus 1 on x squared. Then you plug in infinity. So it's 3 plus 1 on infinity, 2 on infinity minus 1 on infinity. So I am getting 3 plus 0 over 0. Infinity. So we get that? So we still get infinity. Right? We still got infinity. Infinity. Let's check L'Hopital now. Let's check L'Hopital. Differentiate 3x squared and we're going to get 6x. Differentiate 2x and we will get 2. Okay? When you plug in infinity, you're still getting infinity on 2, which is infinity. And differentiate correctly there. Yeah. Okay. Try number 2. Number 2 is what? Number 2 is factorization, right? So you should be able to factorize number 2. Yeah, difference of 2 squares and things. Or they have 2 pi, and then I just gave them 2 pi is 2 pi is yes. All right. Check out the next one. What you'll use for this one again? Factorization, right? So when you factorize x squared, what you get? X squared minus 4, sorry. You'll get x minus 2 by x plus 2. And when you factorize the denominator, you'll get 2x by x minus 2. And what will happen? So you'll end up with the limit as x approaches 12. What's the next step? Substitute. Right, good job, Tavisha. Plug in 2 and you'll get 2 plus 2 over 4, which is? Yeah, Aaron? Trouble? Try number 3, no? Number 3 I didn't show you anything to do with number 3. I did not show you number 3. What we're gonna do? Leave out that. Yeah, that was 3-4 marks. Do that. Sorry? Yeah, you only stop writing limit when it's up. Anybody have an answer for this one online? Think about it, right? I don't know if you remember, there used to be function questions in Form 5 like this. Kind of the same principle. Yeah. Let's see. Sure. How much you get for this? Already moved it out. Put it now. Put them on. You look it up. Point your head. In your head. What's all here? Anything? Okay. It's something good. How much? It's something good, but it could be wrong. Huh? Let me see. Change the subject. Yet China, tam tersebut dan mereka. Right? I'll give you one little hint. Limit as x approaches 3 of f of x. I'm just going to split it up, right? There's a plus sign here, so I'm going to split it up. Plus the limit as x approaches 3 of 2x is equal to 8. If you simplify that properly, you should get the answer. See if that helpful. What you do with this 4 area? What you do with that 4 there? Just put it at the outside. Okay. All right, so it's 4 by the limit. So the trick is really to figure out what the limit is. Try it, let me see. Let's see if any answers online. Tapisha get 8. We have 3 8 so far. All right, so what's this here? What's this value here, Asia? What is the limit of 2x as x approaches 3? What would that be? Every time you have a limit, the first thing you should do is plug in the x value. So what you will get? 2 by 3 is 6, right? So what we really have here is the limit as x approaches 3 of f of x plus 6 is equal to 8. So what does that say about the limit earlier? The limit is how much? What?
No, seriously.
The limit is 2. The limit is 2. All right, so the limit of f of x as x approaches 3 is 2. Now you wrap it up there. 4 by 2, that's 8. All people with SBAs do this week, yeah? Online. To me, I'm free with. So the answer is plug in 4 by 2 and you get 8. Calculating what the limits. We gotta write the limits of 2x. And then yeah.
Everything by 4.
Right.
And then you find
Yeah. You can so you multiply everything by 4. And then but did you still work out this here, right? You still work out the pattern box. Yeah, that? Okay. That can work. That can work. So basically you kind of trying to multiply everything by 4 to make it look like this, right? But you work out this limit, right? As a limit. And you got what? 8 by 324. You must have that. I can't watch it as now. I can't watch it as now. Am I writing? Am I writing? Alright. Next one here. Right, so those were the first set of rules. Now we have tricks. Right? So do me a favor, write down these trick rules here. Right? You gotta remember it. So this is in physics. You gotta remember we did this in physics. We kind of said this in physics.
Yeah.
As x approaches 0, two of them equal. Oh. Technical calculator. Take a small. Okay, let's. Well, I'm going to show you all the steps now, how they got it. I don't like the solutions like that. You have to work out the whole thing. I'll show you that now. Right, write down these rules and let's go to the board. Right, online. You're all there, right? Adrian, Kishore, you understand anything? Emily, Brittany, you there? Kishore, see I call on you and get an answer. Oh, you no answer, you know, it's back. Killing message, yo. Killing him message, man. Tell him to pay attention. So, write down those rules there for me, and we are going to take a look at those type of limits. And technically, that's the end of the theory for limits, and we could start to do some more past papers. Huh? 20 more past papers. And after this, we do the question. Such easy. I wouldn't, there's nothing. Once I get used to first principles, once again, the gradient formula. Y minus y1. What is the gradient formula? I'll show you. They might see also one little question like technique is how to solve it. I way all right, you all have it? Right, let's try out here. Right, so let's try this one here. Right, so if you look at the rule, you might see that markup. Right, if you look at the rule, right, The rule says that sine x on x as x approaches 0, that limit is 1. Right. So this question would have been really, really easy if I had 3 here. That's okay? Because I will have 3x. I will have 3x and 3x. So how do I bring that 3 in there? Well, to bring that 3 in there, I can multiply by 1. But to be more specific, instead of 1, I multiply by 3 on 3. Am I okay with that? Yeah? So when I multiply that, I will end up with the limit as x approaches 0 of sine. So I'm multiplying 3 by this. So I'm putting the 3 on the outside. Remember, don't multiply 3 by this, that's wrong. Eh? It's 3 by this whole thing, and then 3 by x, which is 3x. Am I okay with that? So everything nice here so far, right? I'm going to take this 3 and bring it out here. So I'll end up with 3 by the limit as x approaches 0 of sine 3x over 3x. This whole thing is how much? Am I recording? This will be 1. Sorry? What's that? Everybody okay with this? So you follow what I did? Don't magically just turn it into 3. Yeah? Multiply by 3 on 3. 3 by x is this. 3 by this is this. Then pull the 3 outside using the limit rules. So multiplying by 3 on 3. The reason for that is because you want to get 3x here. So multiplying 3 here, multiplying 3 here. Pull the 3 on the outside and we'll stop. All right? Copy down. Let's go again. But look at the steps I've taken earlier. Any questions online? What's the answer for this one? If you had a guess, hopefully you did it already. Yeah, the answer might be 2/3. But these are the steps I wanted to take in order to work it out. All right? Might be a little long, although we know the answer, but you have to do it properly. All right? Up here down, I want to show you how to do this, right? Talia, are you okay? Talina, Rasnell, you still in this class? Rasnell. She's in your own class. Talina, I can't believe that. All right, so watch this here. In order for this to work, it has to be sine 2x on 2x, sine 3x on 3x, correct? Yeah, for it to work, right? So how are we going to achieve that, Adrian? What we're going to do is we're going to use the limit, divide, we're going to split it up. So we're going to get the limit as x approaches 0 of sine 2x divided by the limit as x approaches 0 of sine 3x. Right? These are the proper steps to take, right? Okay with that? Next, what do I want? What do I want? I want to get 2x underneath here, right? Yeah. So I'm going to multiply by 2x over 2x. Is that okay? Would I change the answer? No. 2x on 2x is 1. What would I do here? Yes. Multiply by 3x on 3x. I write in all these steps, right? For you to see what's going on, right? So this will be the limit as x approaches 0 of sine 2x over 2x. Remember, it's limited this by this, right? So I put in multiply by 2x. Is that okay with that? divided by, I'm doing the same thing here. The limit as x approaches 0 of sine 3x on 3x multiplied by 3x. Everybody okay with that? Right? Don't just cancel off things here. You cannot. Right? Don't just say that this is 1 and then left with 2x. Don't do that. That's wrong. What are you doing? What you're doing is this. The limit as x approaches 0 of sine 2x on 2x multiplied by, I'm putting a dot for now, right? Limit, so it's this by this by this. As x approaches 0 of 2x. You okay with that? I'm going to do the same thing here. Limit as x approaches 0 of sine 3x on 3x multiplied by the limit of 3x as x approaches 0. Right? This value here is how much? This value here is how much? That's okay? If you were to plug in 0 here, what you'll get? You'll get 0, but you don't want that, right? Here's what you're going to do now. Put it 2 on the outside. So you'll get 2 by the limit as x approaches 0 of x all over 3 by the limit as x approaches 0. This will cancel and you will get 2. That's okay? The only other technique that I like is what? If you were to bring it back underneath and you cancel off the x's and then work it out, I'll take that. All right? But you can't magically just take this off and leave it as 2x because this is a product. The limit of this and this. But if you bring this underneath here and you let the x's cancel off, right? And you left it a constant, that will do. Right? You can just pull the constant on the outside after. So that's the way you handle the question, yeah? Questions like because remember, you want to get it in a particular form. So you could multiply anything by 1. Will you change the question? No. And that multiplying by 1 allows you to end up with this. Because remember, you had to reach here to use the rule. You have to get it, otherwise you can't use the rule. Yeah. And then you divide this by this. Okay? So this is the proper way to do it, right?
So instead of changing the 2 left and let's put it one down to the x.
Copy down. Let's try the next one. What are the rules of tan? Same as cos, right? Tan is the same as cos. Sine, sorry. Tan is the same as sine. Tan is the same as sine. All right. I'm gonna take this off, right? Let's try a few like this now. Right? The good thing is we know all the answers, right? Oh yeah, all the steps, huh?
So we have to write like one step we can skip after that.
Some of the things that you can skip over.
Like that one.
This one?
Yeah.
And the chair? Go from here to straight here. I don't know, I can't remember what subject it is. I started to do all the margin in one answer. Right, so I check and see. Oh, no longer with the parrot, from 5 to parrot. Yeah,
So we like some other
huh? It was, remember I had this competition all last year. Huh? All had teachers. Teachers want the rest. And give them numbers. So yeah. Yeah, she wanted to. I guess I'm they want to see that you like to. All right, let's go. Well, we know the answer. The answer is what? Four fifths. Four fifths. Huh? No, because the rule will going to apply. So for now, no, because they won't be able to apply the rule. Right? Let's work it out quick. So you can identify what you're doing already, right? So your limit as x approaches 0 will be sine 4x, all on 4x, multiplied by 4x, divided by the limit as x approaches 0 of sine 5x all over 5x by 5x. Right? And just break it up here and we're done. Right? The limit as x approaches 0 of sine 4x on 4x multiplied by the limit. You can put the 4 in front one time as x approaches 0 of x all over the limit as x approaches 0 of right? This will cancel off and this is 1. So you'll end up with 4 and 5. All right? Everybody give it up? Let's go again. Any questions online? Put the pick. Come on. Pick a name. Pick a name. Put the pick. Saphir. Saphir, you working? See, Saphir never paying attention, boy. Agam, put some over there. I saw what. I tried this one yet. This is 2012. The limit as x approaches 0 of 2x cubed plus 4x all over. Right? Do you think there? All right. Break it up first. Break it up first. Samira listening, most likely Scarlett listening. Michaela is normally listen. Kyra is normally listen. Brasnell, you here still? Emily, you pay attention. Oh, let's Superior message, man. Right, Superior. Some way gets here, Superior. Amanda, a bit charger here. Give it give it Azaria. Oh, she's saying them tomorrow. So yes. And next one, take the she say it. Tell her right here.
Mama, no, you need to message this. Because she's saying I will give an excuse.
Take your time, break it up, and let's see what you get. Break it up, right? This divided by this, and then apply the rules, right? That's why you can say, I want you to get that first, right? Yeah, go ahead now. Much higher for you? 100? What? Oh, we did for the rest of the week, or? I don't know. I'll get 2x by x squared plus x plus. Oh yeah, break it up and do the same thing again. That's how you put this for you. Which man on it? Yeah. Answers online. Let's see what we got. I see tools, plenty tools here earlier. Maybe two. Plenty tools. My phone. All right, so how are we doing this here? The first thing we can do, we want to get 2x here. So we can multiply by 2x, divide by 2x. So you'll end up with the limit as x approaches 0 of 2x cubed plus 4x. I don't want to bring it in here as yet, right? Right, so you can probably factorize if you want, and then you will see what will happen there. But in case you didn't see it, I'll leave it like this. Divided by the limit as x approaches 0 of sine of sine 2x on 2x multiply by the limit as x approaches 0 of 2x. What will happen here? That's 1, right? So you're going to end up now with this divided by this. Go plug in 0, right? So therefore, if I have 2x underneath and I have this on top, I might be able to do some factorization. No? You sure? 2x by x squared is 2x cubed. 2x by 2 is 4. Divided by the limit as x approaches of 2x. Right? What will happen here now? This will be the limit as x approaches 0 of 2x multiplied by the limit as x approaches 0 of x squared plus 2 all over the limit as x approaches 0 of 2x. This will cancel, and then I can plug in 0. So I'll get 0 squared plus 2. But it wasn't coming. Huh? I get rid of it. I go again. Huh? That's good. Thank you. Pretty hungry, so that's what that is. All right, come here, let's walk in. This is still the class, yes, sir? All right, let's go again. Everybody okay with that? Yeah. So let's try. I know this will be hard for those who didn't revise, but let's try to bring it together with what we did last week, right? Trouble? Yeah. You sure? You sure?
Why can't you divide by the highest power then?
Because what told you have to always apply first. Always factorize first. If you can't factorize, then you can divide by the highest power. Because if you divide by the highest power, what you got? Right. Okay. Any questions online? Online? Let's go again. No questions online. All right. No questions, Kyra. None? I think of one, Kyra. I know that's what you would have seen before, but you see, there are little things mathematical that you can't answer. It's like kind of like the sine function, like you try to just divide it out. I don't like it, that's why I don't like it. All right, let's combine what we did today, what we did last week. Yeah. Let's try this here. I don't know. I actually don't know what year it is. Online, I had to stop this online teaching. From face to face, let's take that. Brittany, you paying attention? Yeah, no, Amanda. Who have the count on? Adrian, you there? Count on Amanda, Christopher, Emily, Ishmael, Bob. Let's see how much I get out of the 5. I get Bob, nice. 1 out of 5. Ishmael, 2 out of 5. Good. Hey, break it up. Break it up from the mouth. I'm looking like it's good from mouth. Try this here. Should be. One ahead. We got to say no or oh.
A little bit. So,
That's all you said? All right, let's go, Ole, come on. I'll give you a break just now. Around half past. So we finish the theory, just do some more questions on limits, right? Hey, just work it out now the year, though, every year.
that's fine.
Right, so it's a mixture of what we did last week to show something continuous, right? So the question said, if it continuous, find the value of A. But do like the pen also remember it. Don't make it so hard now. Right, so remember if something is continuous, what are the two rules again? The limit, right? And it must be equal to, right. So the limit of f of x as x approaches 0 should be equal to f of 0. So in this question, what is f of 0? Very good. X equal to 4 is defined when x equal to 0 and the answer is 4. So basically, you're trying to figure this out. What is A? What is A? Try something quick. Nothing changes, the same thing that we did before. It's just you know what the answer is now. I know. Yeah, I'll give you everything over. Have you finished it, Terry? But I want to do a couple more questions. Don't know what to do? Right. So if you look here, right? Look at the board. Right. The only way you could use the rule is if what? If you have AX here and also what down there. So right, multiply by A alone? A on A. So multiply by A on A. So what you'll get? this A comes out here, and you'll get A by the limits at x approaches 0 of sine AX over AX is equal to 4. This here is how much? 1. So A by 1 is 4. So A is. That's all. Let's go again. Anybody got that online? Samir, Tavisha, Samira, nice job, all. Let's go again. Olive. I still have class sometimes in May for those who think they can merit it. But you can only think about that if you have full marks in it. If you don't have full, don't think about it. Just try and get out. Right? I'll talk to about that after. So you had to get full marks in SP. Huh? You have to talk to them and try to make sure they get full. Like us. That's where it starts. Right, let's go again. Let's go again. But this first principle, oh no, ignore that. So let's set up teachers that they're co-demand analysis.
Yes.
This one already? Yes, sir. Now, let's go again. Let's try this next one here. Determine whether or not the limits at x equal to 1 exist. I don't know the yet. This is on the sheet. This is on the PDF I sent you. So you have to work all the limit, right? Left to right. Take your time. It seems to do the one to write here, right? Yeah. And if it's left, how do you know which one to use? Less than. That's the left, not negative, less than. And if it's from the right, it will be? Right, online, just message yes or no. I know it didn't ask, but do you all think it continuous? Yeah. Yeah. No, f of 1 is 2. As the approach from the right is how much? Can be continuous. Right, so remember for limit to exist, right, you have to approach from the right, it have to be equal to the same as the approach from the left. Okay, so if you approach from the right, you're using here, right? So the limit at x approaches 1 from the right, we're using this function here. Right? So you just put in 4 by 1 and you get in 4. Now, as it approaches from the left, the limit as x approaches 1 from the left, we have to use x to the 4th minus 1 over x minus 1. I'll do that. We better simplify that. Right? So we had to check and see if we could factorize, or check and see if we could divide by the highest form. Look at that difference of 2 squares. So you can factorize that. X to the 4th minus 1 to the 4th is the same as x squared squared minus 1 squared squared. Recognize that? It's difference of 2 squares on top. That expands, right? Okay. Take it long divide and get it. So you'll end up with x squared minus 1 by x squared plus 1, right? So you still have to remember your form 5 expansions. Huh? Anything canceling off of that? No. We don't know what to do. Nothing cancel off of that. Factorize it. Rihanna? So you'll get x minus 1, x plus 1 all over. Now you're getting a canceling off. Okay? And now we can plug in 1. So if I substitute x as 1, I put the answer to the left here, right? I'll get 1 plus 1 by 1 squared plus 1, which is. So does the limit exist? The answer is limit exists. Let's see what these people got. Tavisha got yes. Aidan got yes. Very good. Okay, then follow up going on. All right. So these are what the limit questions will look like. I finally forget how we did last week. Yeah. You should happen. Oh, okay. So the next part is if it's continuous, and the answer is no, because f of 1 is f of 1 is 2. All right. So these are what the limit questions will look like, right? Generally, it looks like this. You have to remember what we did last week and this week, right? Because not all is simplifying alone. I find looking out. We had to practice plenty, right? So I'll do some more. So our next thing that we have to do, let's squeeze in one more. Oh, no, you can hold that one. I do have crash this. 19 to 24 is crash. 3 and 3 is crash. Any questions online for this one? Let's see if we can squeeze in one more now. Online, any questions? Emily, any questions? Good. Wait, have no more? I will just pay this now. All right. I'm not seeing any more on this set. For 1 second. I'm going to see if I get one here and then you. If not, you'll take up. All right. Take a little bit. All right, so take a little break. We start back at past. 10 good? Minutes break.
Yeah.
15? Right, so in 15 minutes, we'll start back and we're going to start differentiation, first principles and differentiation.